we're going to continue. Is there any question, people? Is there any question for Engineer Isaac? I don't see any question. Go on, Isaac.
Okay. This is the second exercise. So this is a plate with center holes. The plate is on square. So the length of this square is 500 millimeters, and the radius of this hole is 25 millimeters. So this plate is subject to tensile stresses, and the stresses is 1 kilonewton per meter square. So this is the Young modulus and the Poisson ratio and the thickness. So the thickness is 5 millimeters. So to draw this part in the ANSYS, so the first two steps is the same. So you have to drag the static structural to the Y space, and then click on design modeling. So next you have to draw these lines and this cycle. So then you have to assign to this line and the dimension in these forms, 2 horizontal dimensions in this way, and these 2 vertical dimensions in this way, and then the radio to the holes. Input the value for each dimensions, and then this is the geometry. Next, you have to create, in this case, is not a line, is a surface. So you have to create a surface from the previous sketches, and then you have to apply and generate. And this is the surface. So next, the new step is this surface, the thickness you have to assign. So in this case, is 5 millimeters. And that's all for this exercise. So now I'm going to do in the program. Okay, so draw a new static structural in the side to the previous one, and then right click in the geometry and select new design modeler. Okay, we're going to work in the XY plane. So click in XY plane and then look at face. So go to sketching and select, in this case, a rectangle. Select a rectangle and then select this point to the center. And first, check the units first. Check the units. In this case, the dimension is in millimeters, so it's better to work in millimeters. Okay, so units, this case is meters, but I use millimeters. Okay. Select a rectangle to this point there, to other point, and next, and Okay, Thais. Go on. Thais.
How do I erase the
Okay, okay, that, okay. Select the lines, select, and delete.
Delete.
okay?
Delay is
Thank
something
you.
different.
Delete.
Delay, we have to be careful. Delete,
Okay.
delay is
Delay is
being
for the
behind.
time. Okay.
Yeah.
Okay. Delete. Select the line and delete.
Thank you.
Okay. So rectangle to this point, from this point, and then select a cycle, this cycle, and draw in the inside the square. Okay, there. So this is the geometry, and then you have to assign the dimension. So go to dimensions, and select horizontal dimensions, and then you have to click to this point, for the length of this square, and then this point to this point, this point to this point. I don't know. Or this point to, yeah, to the y-axis. Okay. This is for this is in order to put the cycle in the middle. Next, select vertical dimensions in the verticals, the vertical distance, the vertical end, the vertical sides. Okay, so to this point, to this point of vertical dimension to this point. Yep, to this point there, and the same to this point to the x-axis. And finally, the dimension of the cycle to this. Okay, so click on radius and select the cycle. That's all. So 2 horizontal dimensions, 2 vertical dimensions, and the radius to the cycle. Okay. And next, and then you have to.
Is there any question, people? Is there any question, people? Is there any questions? Mr. Ordóñez, Mr. Ordóñez, are you here? Mr. Ordóñez,
Yes.
Are you with us so far?
Yes, doctor. Yes.
Mr. Barba, Mr. Barba. Mr. Barba.
Doctor.
Are you okay? Are you with us?
Yeah. Yes, of course.
Okay.
I understand.
Okay. The problem is that I called you a few minutes ago and you did not answer. That's why I'm calling you back. That's all. Okay, go on, Isaac.
Okay, so H1 and V3 is to form a square. And the H2 in V4 is to put the cycle in the middle. And the R5 is to form a cycle, right? So next, you have to input the value. In this case, H1 is 500 millimeters, and H2 is 250, 250, and V3 is 500, and V4 is 250, and the Earth fight is with the value 25 millimeters. So it's 25 millimeters there. So this is the geometry. It's a square with these center holes. Okay. Questions so far? Questions? Okay, I will continue. So the next step is go to modeling, and then click on XY plane, open to XY plane and select these sketches. And then you have to create surface from these sketches. So go to concept, and in the previous exercise, remember that we use line from sketches because this is a beam, but in this case is surface from sketches. Okay, surface from sketch. So select from surface from sketches, and this is surface, and you have to apply to these sketches. So click on sketches and apply. Then you have to generate. Okay, I going to do again. Okay, delete
Elite.
Yes, yes. Okay. So then again, okay. So select sketch 1, concept, surface from sketches, and then click on surface from sketches. You have to select this sketch and then apply. So finally, you have to generate. Click on generate. There. This is a surface, but in this case, you have to enter or input the thickness of this plate. So in this case, is 5 millimeters, and that's all. 5 millimeters for this plate. That's all for this geometry. Remember, always save. Oh, no, save.
So in the same project, you have the two structures.
Yep.
Exactly.
Engineer,
Yeah.
I have a question.
Yep.
And don't click again the generate after to save, or doesn't matter?
You have to first assign the surface. Okay. The last step is click on generate. The last. If you don't click on generate, the surface is not created.
Thank you.
Is you okay? So close this part, and in this file, as a doctor says, we have the two exercise,
Wow.
geometry of the bridge, and this case you can renames plates with holes. Okay, so that's all. Always save the project. Always, always, always. So that's all. So when so if you see the folders, what is the folder? ANSYS practice, you see two folders, practice one files and the files backup and the file the ANSYS workbench. So when you move this program, you have to move everyone because it's work together. So always you have to move everyone because the program works together. This driver to the folder. Okay, I don't know, questions?
People, is there any questions about this? Okay, I want you to practice this because that's what we need to do, okay? In the meantime, when is the project due? When do you have to turn in the project? Anybody? When is the project due? When do you have to turn in the project, people?
16 and the presentation 22.
16th, that's this Thursday, right? Okay. So on 16, I will assign a homework about these practices. Okay, so you will have to do a frame, a ship frame, similar to the bridge. You're gonna do a plate with a hole, different than the one very close to the one that you just showed. And you're going to do a plate, part of the hole with the frame, attach a frame to it, okay? So right now you have to concentrate on the project. Okay, about the project, is there any, oh, before we leave, there is a comment from somebody in the chat. Please, Isaac, would you answer that? Will you comment on that?
What question?
No, it's
yeah.
somebody says that they had the 2018 release 3 version.
Okay, and this is it's not the version that we're going to use in this course. So you have to install the other version, 2021 ERBS 2. Otherwise, okay. Otherwise, the program don't run your program. Okay.
Yeah, the thing is that we have to check your results. So you have to upload, when you complete the homework or the project, you have to upload your work, and Isaac had to check it. So we don't want to have 3 or 4 versions. We just have one version, and that's 2021 release 2. Okay, so that's the version that everybody has to work with. Okay, so that's the official version. Remember that our university is paying the fee for the license. So we have the right to use the latest version, and that's 2021 release 2. So that's the one everybody has to work with. Okay, people, is there any questions about the project? Any questions about the project?
I have a question, Doctor.
Go on.
I don't know how the units or what units use because I was checking in the Logan's book, but they use English system, and I don't know if I have to convert from centimeters to inches and use in this system or
Okay, that's a good thing because units, you see, Engineer Isaac insisted several times, units are very important, units are very important, okay? In this case, okay, we want to calculate the stress concentration factor, and that's a non-dimensional parameter. So the final result is a non-dimensional value. So doesn't matter if you work in any system of units, as long it is consistent. And the final result, there's no problem because it's non-dimensional. By definition, the stress concentration factor is the largest value of the stress divided by the mean value in a certain area. That's by definition the stress concentration factor. So you have stress divided by stress, so the result is non-dimensional. Mr. Zamora?
yes, doctor.
Okay. Any other question, people, about the project? It's due this Thursday.
I have other question, but
Yeah,
it
go on.
is in particular with my project because I don't know how I was using a type of boundary conditions, but
What we can do is this. If you want, you can stay and I'll talk to your team
okay.
in a private room. There is no problem for that. Is there any other general question that I can answer to everybody?
Doctor, I have a question, sorry. Carrillo.
Yeah. Go on.
Yes, last day I listening is about we have the work and the project three different reasons. That's okay. Is other listening is about the three discretization different. Is correct?
What I need is not 3 discretization. What I need is a convergence analysis. I can do a discretization with 2 elements. I can do a second discretization with 4 elements, and the third discretization with 6 elements. That it's not going to converge at all. So don't say that you need 3 discretization. Say that you need to check convergence. And to check that, you need at least 3 values. So you can check that the tendency, it's getting it's softly being transformed into a horizontal tendency. If you get a horizontal tendency, that means that you are getting close to the correct value. Yes, you need at least to give me 3. If you give me 2, right, it's going to be different. But you don't know if you are close to that, or we simply have to keep going up and finally bend to a horizontal value. So yeah, you need to give me 3 discretizations. But remember that you really want to give me is the assurance that you are close to the correct solution.
Thank you.
Okay, no problem. Okay, if there is no more question, then I'll see you Thursday. And please try to review the material about the second part of this training, okay? And the second part is really very well explained. The thing is that you have to generate what we call a geometric model. When we say geometric model, for example, you have a line, but this line has no dimensions, transverse dimensions. There's no transverse section. It's just from here to there, that's all. When you have a surface, it doesn't have thickness. So that's a surface, that's not a plate. Okay, so using rhinoceros, you can generate very complex geometries. Okay, and that's the best way we have found. Okay, and you can recognize immediately that the surface of a ship, the whole surface, is a very complex structure. Okay, so what we can do is we can use Rhino, which you know already how to use it in order to prepare what we call the geometric model. So please review that part. And from there, you can import from ANSYS, you can import that model, right? And in ANSYS, you can complete it. For example, if you have a beam, you can define a transfer section for that beam. If you have a surface and you want to represent that with a plate, then you can assign a thickness, you can assign mechanical properties. And with these two things, okay, geometry and all of these properties of the structure, finally, you generate the model of the structure. So you convert a geometric model into a structural model. And from that point, you can go on. So please review that so we can save some time on Thursday. Okay, if there is no question, please, Zamora, stay in the session.
Doctor, I have a question.
Yeah, go on, Larrea.
When is the presentation of the project? Because in the mail say the Wednesday 20, but the 20 is Monday.
Oh, I'm sorry. Then it's Wednesday 22nd.
Yeah, thank you.
See, on Monday we have evaluation in the morning, okay? And on Wednesday we will have presentation of the project. Mechanical variations we have on Tuesday, we have lab. So that's what somebody made me notice, that originally I had evaluation of vibrations on Tuesday. So we changed it. So you will have evaluation on finite elements on Monday and evaluation on mechanical vibrations on Wednesday. So you had 2 days to study a little bit more. That's what they say. So Monday, evaluation, quiz. Wednesday, presentation of projects in person in the faculty. Larrea?
The evaluation and presentation is in person.
Yes.
Okay.
Yes, yes. So yeah, you have to come to Guayaquil again. Don't worry, the weather is fine. A little bit of rain, but that's all. It's gonna be nice to see us again. I'll try to prepare something decent to share. Remember that that's the way to do it last October. It was fine. It was I really enjoyed. Okay, Ms. Kumbe, do you have any question?
Yes, doctor. It's about the graph, the coefficient is about the graph. For it to the converging, and I need it the exact solution. Or
and you don't know
for
the
the
exact
comparison.
solution. You don't know and nobody knows the exact solution. That's why, let me try to draw. Let me try to draw. Here. If we can. You see my white screen? You see my white screen, people?
Yes, doctor.
Okay. Remember that this is the number of joints. Okay. When you have an infinite number of joints, you have the exact solution. When you have a discrete number of joints, you are away from the exact solution. So let's call it, this is star. So if you give me the solution, two solutions with two discretizations, you're going to give me this and that. So you give me 2 points. But the problem is that these 2 points, you can say, okay, there is a difference, but this does not allow me to see how close you are from the exact solution. That's what we need 3. So if you give me 1, 2, and the last one give me something like that, you see that this is bending in this direction. So it's telling me that you are close to getting horizontal, okay? If on the contrary, you give me something like this, 1, 2, 3, you're telling me that you are not bending in this direction. You are still away from the exact solution. That's what we need 3 in order to see if you are bending towards the exact solution. Ms. Kumbe?
Thank you, Doctor.
No problem, no problem. As I said before to Mr. Carrillo, okay, I could have, for example, let's suppose I have a plate, okay, with this. I could have something like this. That's my first partition. My second partition could be something like this, okay? My third partition could be something like similar, okay? Three partitions here. The problem is that I don't think you're gonna get any close to the exact solution with 3 partitions. So what I'm asking you is to prove me that you are close to have this type of behavior. So the first 2, they're going to show some difference, but the third one, it's clearly that it's not following this tendency. It's being bended and converted into slowly into the exact solution. Okay, of course you need more, but this is telling me that it's kind of close. That's what that the convergence analysis is all about. Okay, just to be certain that we're close to the exact value. Okay, is there no more question? Is there any other question, people? Anybody? Okay, Mr. Diaz, you have any question?
Doctor, I could to assume the result, the convergence if the 3 values are so close.
The problem is this. Give me a definition of close. It's very, I mean, the thing is here. Okay, if you have one result like this, one value here, the next one here, so you can try to do some sort of join them with a straight line, and you see that this point here is well below the value following this straight line. So you see that this is bended, right? So it's telling me that you are getting close to being completely horizontal. So this in this area, probably you're going to have something like this. So this is telling me that you are being bended and following tendency. While in this yellow situation, you see that the 3 points, yeah, this one here is a little bit bended, but not much. So are you convinced that these 3 with these 3 partitions, are you convinced that you are close to being close to the correct solution? What do you say, Mr. Diaz, with these 3 yellow results? No, exactly. It's telling right there, you're telling me that you're not close. So you need to have another partition. Probably the next one will be something like this. And now you see that it is being bended. So it's telling me that you are close. But that's something that we should always do when we do finite elements. We should always be worried about the question, how close am I from the correct solution? Because remember, that's something that we have insisted in this class, is that finite elements is a very, very fine, very nice, very useful, flexible tool, but it's not exact. Okay, is there any other question, people? Oh, well, please, Mr. Zamora, stay in the room, and I'll try to answer to your concern. Okay, people, I'll see you Thursday.
Thank you, doctor.
Thanks, doctor.
You're welcome. Mr. Zamora, who is in your group?
Walter Arias and Carolina Gutenberg.
Okay, go on. Go on.